My name is Mohammed Faisal Khan. My project title is Productivity Improvement of the DDU line. I have completed my project from Webco India Limited Jamshedpur. About the company, Webco Jamshedpur design, manufactures braking product, advanced braking system and other related air-assisted product and system. Webco India employ over 3,200 employees and reported 1,138 crore sales in 14-15. Jamshedpur plant mainly supply to the Tata Motors. Webco headquarters in Brussels, Belgium. Abstract. This project analysis is the production of drying and distribution unit by the help of several quality tools. Identified some cause which decreases the productivity, which is showed by the cause and effect diagram, and provided solution to solve this problem. The parameters that mainly affect the productivity, that is man, machine, material and method. Identified top 7 causes which affect productivity, that is a spherical valve without thread, variation QSPB 4 volt, gasket thickness less skill levers, material shortage, defect during transportation, skip impregnation process and machine breakdown. For the impregnation defect, the data for with impregnation and without impregnation is collected. Fisher reject test is done to comparison of two data in which significance variation. Then after performing the test, it is clear that without impregnation productivity becomes less and impregnation process is chosen to improve the productivity. The solution for the problem is given and thus it is implemented on the DDU line. The production rate of company on daily basis in making DDU is 202 pieces. Usually production rate reached about 160 pieces approx. After the completion of project, company has reached 190 pieces daily. Productivity has improved by 20%, which increases the revenue of the company. Project achievement. Project benefit increases in productivity, improve customer satisfaction, elimination of customer complaint, reduce assembly rejection. Tool used for this project: fishbone diagram, histogram, fast pass yield and Fisher exact test. Product introduction. Drying and distribution unit is used to make air dry and dust free to distribute to all accessories. Location of the DDU in truck after the compressor in the middle of the chassis. Components and feature of the DDU. Pulse tank. This tank, which is integrated with the DDU, stores dry air for regeneration of the desiccated. Quadruple system production valve. This function is integrated into the DDU, which protect the healthy circuit of the air brake system. In case of failure in one of the circuits, the non-return valves in this portion prevents backflow of stored compressed air upstream. Safety valve. In case of any malfunction of the unloader valve, it protects the compressor and system by blowing off the excess pressure. This device is integrated with the unloader. Air drying. Remove moisture completely from the compressed air. Tire inflator. This device helps for inflation of the vehicle tires. Layout of air braking system. You can see in this figure drying and distribution unit having mainly 4 ports: 21, 22, 23 and 24. 21 number port is goes to the reserve tank. 22 number port is goes to the air cylinder with solenoid valve. 23rd number port is goes to the brake actuator, spring brake actuator, and last one is goes to the graduate hand control valve. About DDU workplace. Total number of the workers in the DDU line is 11. Here we finished only assembly and testing. All materials came from the wastewater plant and from another company. A process flow. First of all, in company we did the unloader bar assembly and testing Then we go to the NRV assembly and testing. Then after go to the purge tank assembly similarly. And last one is the PDI. That means product development inspection. Cycle time of each station. This, this is all are the station of the DDU and cycle time of each station. You can see in this figure unload in this table. Unloader valve assembly and testing takes 60 seconds. Non-return valve assembly and testing takes 150 seconds. Pulse tank assembly take 160 seconds. Corner valve assembly take 150 seconds. Corner valve testing takes 165 seconds. Wash assembly take 60 seconds. QSPB assembly take 180 seconds. DTU final test take 185, and last one pre-delivery inspection takes 60 seconds. Literature review. These are the literature review. Methodology used. First of all, collecting the production details and assembly rejection details of 1 month with the help of DRM board. DRM board means daily routine management. Analysis of data collected in order to identify, measure, or prevent defects. Implementation of check sheet in order to capture number of assembly rejections. Identify frequently rejected parts with the help of histogram quality tool. Determine the reason for less production using cause and effect diagram. Provide solution to solve the problem. This is the production details of January month. We can see in the table, this is the whole month. This is the production details of whole month. First, second, third, fourth. Daily target of the company is 202, but company reached only 135, 150, 125, 142. Daily average company reached 150 pieces of DDU. Company daily target 202 pieces, but we reached approx 150. This is the graphical representation of production. Parts used in assembly: spherical valve seat, NRV body, gasket, plunger, unloader plunger. This is the assembly rejection of January. For finding the first pass yield graph value, we have to use this formula: total production upon total. This is the forum chain sheet of the company that is taken from the DRM board. Top 7 potential cause identify, that is impregnation process skip, torque variation in QSPB 4 volt, spherical valve without thread, gasket thickness less skills, material shortage, machine breakdown. That is the top 7 potential cause that affect the productivity. Impregnation process skip. Impregnation, this process done before the assembly of parts. Reason behind the torque variation in 4 volt. First is volt runner is not fully automatic, variation in power supply, and third one is at the time of tightening bolt not clamp. We can see the result of this project. This is the first pass yield graph of January. We can see in this graph that graph is not straight. We can see in this graph variation is more, and after the completion of the project we can see the second graph of March month, that variation is very less. Conclusion: assembly line plays an important role to improve the productivity. Assembly line provides 100% accuracy, so the failure mismatch in production completely eliminated due to the assembly rejection is reduced.